So the first thing that we're going to do is we're going to use factoring in order to do it. So if we can get the equation in this format where ax squared plus bx plus c equals 0, with of course a not being 0 because then it wouldn't be quadratic, it would be linear, then we can actually solve the problem by factoring, hopefully. So this is called the zero product property, because if we can get two things multiplied together, so usually there's something in parentheses, that means that either this one is 0 or this one is 0. And that's what the zero product property tells us in a long sort of way. So any numbers a and b, if a times b equals 0, then one of those things has to be 0. As you can't get 0 with two non-zero numbers multiplied together. So let's do an example of this. Solve the equation 3x squared plus x minus 2 equals 2. See, I've already done the first step in my head. So if we subtract 2 from both sides, we get 3x squared plus x minus 2 equals 0. And now we want to attempt to factor it. So we look at my 3x squared and we think, okay, that's got to be 3x and x. There's no other way to do it. And this one has to be 2 and 1. But if I know if I put the 2 here, then my outsides are going to be 6, with my inside only being 1. And that's just way too big. So I know my 2 is going to have to go over here. So I'm going to want 2 and 1. So now I want a positive x. So I think it's going to be on this one, so that my outsides are positive 3x minus 2x. So my first, outside, inside, last, I end up with 3x squared plus x minus, 2, not 1, sorry. So I know I've done this right. So by the zero product property, which I like to call the zippy, so by the zippy, we know that either 3x minus 2 is 0 or x plus 1 is 0. So we can easily solve these two equations. 3x equals 2, divide both sides by 3. X is either 2/3 or x is equal to negative 1. So we can easily solve that equation. We found the zeros of the function. And we can, if we want to graph it or whatever we want to do with this, we can. So let's talk about that height of the ball again. So the height above ground of a ball thrown upward at 80 feet per second from the top of a 96-foot high building. So for some reason, we're standing on the top of tall buildings throwing a ball up. I don't know why, because math, that's why, is modeled by this function, 96 plus 80t minus 16t squared feet, where t is the number of seconds after the ball is thrown. How long will the ball be in the air? Okay, I want to look at this graphically first. So I'm going to pull out my graphing calculator. And I'm going to go y equals, that was something else that I did before, 96 plus 80x, because I don't have t in here, plus 16x squared. All right, so is that plus or minus? Oh, it's minus. I was thinking that's gravity. That should be negative. Okay. So let's see what this looks like. I'm just going to zoom standard right now, but I don't think that's going to work very well. No, it doesn't. So we know that this is, since this is negative, it's negative 16t squared plus 80t plus 96. We know this is a sad graph. And we know that the vertex of this graph, and is going to be a maximum, and it's going to be at negative b over 2a. So that's negative 80 over 2 times negative 16. So these negatives will cancel. 80 divided by 32. Let's see, what is 80 divided by 32? Let's see, just divide them both by 16, and I would have 5 halves. So I would have 2.5. So my max is going to happen at 2.5. Well, that looks about right. Right in there somewhere. And what's it going to be? So I have to put this in. So at 2.5, how high is that going to go? So if we go, if we go 2.5, so let's just go ahead and find out what it is. So let's get my y function here. What is my y function at 2.5? It's 196. So I know that this function has to go as high as 196. So when I go to my window, I know that my y max has to be at the very least 200. So let's see what that looks like now. There we go. There's our complete graph. So now it's a lot easier because we can find this out because we have that point 2.5196 that we do without the calculator, and we know exactly where to make that window so that it's going to work perfectly. I mean, I could probably take it in a little bit here and here, but it's fine. So there it is graphically. And so remember, the x coordinate is t, how high the ball is. And the y coordinate is going to be the height of the ball. And remember, it was thrown from 96. So it was actually thrown from this point right here. So if you see where time is 0, that's where the ball was thrown. So after 2.5 seconds, the ball is at its maximum height. And the question is, how long will the ball be in the air? So if we look at the graph of that again, the ball is going to be in the air from this time down to this time right here. So we need the 0 of this function that is positive, not the negative, the positive 0 of the function. So let's see if we can find that. That means we want negative 16t squared plus 80t plus 96 equals 0. So I'm going to start by doing it by hand, and then we'll check that on the calculator. Well, I'm noticing a couple of things. I can factor out a negative 16. So is there something I can take out of everything? Yes, there is. So I end up with t squared, and then 80 divided by negative 16 is negative 5, because a negative times negative is positive. And then 96 divided by 16, that's 6, minus 6. So now I can divide both sides by negative 16. So now I just know that I have this. And this I can factor, right? Easily. I don't have to factor this hard thing. I can factor the easy thing. So 6 can be broken up in 2 different ways. It can either be 2 and 3 or 6 and 1. Now, your first inclination, I know, is probably 2 and 3. But the problem is that one's positive and one's negative. And if that were the case, then this t would have to be 1. It would have to be a 1t. So that's not going to work. So the other way to break up 6 is 6 and 1. So we're going to have a minus, because we know that the larger number is minus because this number is negative, and a plus. So we have either t equals 6 or t is negative 1. Well, we know we don't want negative time because that doesn't make sense. So t equals 6. So that is the question. How long will it be in the air? The answer is 6 seconds. That's how long it'll be in the air. Okay, so let's talk a little bit more. So one of the important factors in algebra is the factor theorem. So all of these things, I've drawn this little chart to basically say that all of these things are the same thing. So f has a factor x minus a. So we have some function of x, and if that function of x can be factored as x minus a times some other stuff, that is the same thing as saying x equals a is a solution to it, to f of x equals 0. Because if this is 0, then either the other stuff is equal to 0 or x minus a is equal to 0, which would mean x equals a is a solution, or an x-intercept, or a 0. So in other words, f of a equals 0. Okay, makes sense, right? And x minus a is a factor of f of x. This is almost saying the same thing, these top and bottom. So if I took f of x divided by x minus a, I get that other stuff, and I don't get anything added on at the end. So it goes into it evenly, similar to how if I said, like my 80 and 16s I was just talking about, that goes in evenly. I don't have anything over here. So, how does this help us? Well, let's do this example. What I want to do with this, which is almost the same as the one I just did, but that's okay. Actually, it's not. This is plus 6. So I want to do the same thing that I just did. I want to say, what are the factors of x squared minus 5x plus 6? So let's find that out. So let's see, x is 6, 2, and 3. Since this is positive, these are the same sign, and they're both negative. So the factors are x minus 2 and x minus 3. So what are the solutions of, if this is f of x, sorry, of f of x equals 0? Well, 2 and 3. Because I can write it x minus 2, x minus 3. The zeros of f of x are 2 and 3. So I could sit here and I could do all of these things. And f of 2 is 0, f of 3 is 0. And you can check that answer here. So f of 2, that would be 2 squared minus 5 times 2 plus 6. So 4 minus 12 plus 6 is 0. And f of 3, 3 squared minus 5 times 3 plus 6, 9 minus 15, oops, 6, not 16, plus 6 is 0. So we've checked both of those. So we can actually state everything that we were just talking about in the previous slide. So now we're getting into profit. So this is the new stuff. So consider that daily profit. Daily profit. Any Harry Potter fans watching? Okay. So from the production and sale of X units of a product given by P of X equals this wonderful thing that I'm not going to restate. Use the graph to find the levels of production and sales that give a daily profit of $1,200. So that means that we want 0.1x squared plus 28x minus 270 equals So we can use the graph to find that. So let's go to our graphing calculator again and go to our y equals. Oops, go in there. There we go. And let's put this in here. Negative 0.1 x. Oop, did that negative make it? Nope. Negative. Come on. Negative 0.1 x squared plus 28x minus 270. And then we want y2 to be the other one. So now what we can do is, well, I need to go to window. I need to know where to put this window. I have no idea where to put this window. So I need to know where this hits its maximum, which is, well, the highest profit can be. So I need to know what to make my window. So negative b over 2a, negative 28 over 2 times negative 0.1. Those are positive. So 28 divided by 0.2, which is 280 divided by 2, which is 140. So let's find out what my y1 is. So go back and get y1. Oh, I need to unlock that button, sorry. So I'm going to go get y1 at 140. And it is negative. That's not good. Negative 70,940. Let me make sure my y1 is still negative in the front. It is. Okay. And that's what it is. All right. So that means that this, and since this is a sad graph, this is the maximum. So that's not very good. And I'm doubting that that's right. There must be a mistake. I must have a mistake in here somewhere. That's right. Negative 28 over 2 times 0.1. Okay, sorry. Somehow my calculator was not accepting the new number that I had in there, so something was wrong. This is a terrible picture, but we'll get it fixed in just a second. So what we're going to do is, once again, for some reason it kept giving me that answer. Don't know why, but whoops. Vars, y vars. So I rewrote the function in there, and so this should now be correct. There we go. That makes a lot more sense. So at 140, our level of profit is 1690. So let's go and look at this now. Now we know where to set the window. So I'm just going to start with 0. I'm going to go up to 200. It says it stops at 140, but, well, let's go a little more. Let's go 300. Because that puts my top in the middle there. And then definitely don't need to do that. So I'll just do negative 10. That's fine. And I think this is a little overkill too. So let's do 2000. And let's fix our scales. Probably 20 and maybe 100 for the Y scale. Might look good. So let's graph it. Beautiful. So now we can see a couple of different things in here. We can see where the levels of production are. The levels of production and sales give you a daily profit of $1,200. So it's here and here. So let's use our intersection command on your calculator. Number 5, first curve, second curve. I need a good guess. So I need to go over here. Too far. Come on. Get closer. There we go. Enter. So it is 70. So x equals 70, or there's another one. So I have to run intersection again. 5, first curve, second curve. And then now my guess. Go on, keep going. Okay, there's my guess now. And now my guess is 210 or 210. So we'll notice that it hits there 2 times. And this is units. So this happens, so A happens at 70 or 210 units. So it happens twice. There's 2 levels of production and sales that give that daily profit. And we already know the highest that the profit can be. The highest the profit can be, we figured out in order to get a nice graph. So that was 140 units at $1,690. Because, think about that, the reason that goes back down, that's the point at which we've saturated the market and we have to put things on sale in order to sell them. So I just want to kind of do an aside here. And how would we do this if we didn't have a graphing calculator? So I wanted to do this just to make sure that everybody knows how. So remember, when we're solving a quadratic equation, we have to subtract to get everything on one side and 0 on the other, okay? Anytime you have an x squared in there. 0 on one side, everything on the other. So we have negative 0.1 x squared plus 28x minus 1470. Now, this looks really hard to do, but what if I multiply both sides of this equation by negative 10? So on this side, negative 10 times negative 0.1 will just make x squared. This one will be minus 280x plus 14,700 equals 0. So now this makes this a little more difficult because we have to factor this. But x. So we have to figure out what factors of 14,700 add up to 280. So we think, okay, 70 and 210. Boy, it's a whole lot easier once I've already done it, isn't it? Minus, so x is equal to 70 or 210. So this was a lot easier to do using that calculator and using that technique. And then, of course, to find the profit, we found the number of units that gave profit, and then we would just have to by hand go negative 0.1, 140 squared. Forgot my x right there. Darn x. Plus 28x minus 270. Or 28 times 140 rather, sorry. So to use my calculator for that by hand, 0.1 times 140 squared plus 28 times 140. Come on. Minus 270. And it's 1690. Now, you'll notice I had a little issue with my calculator up here. And I think I had some typo, when I typed in Y1. So I was going to the old Y1. So when I looked at this, remember, I was just kind of like, that didn't make sense, really, especially if I wanted a production sales to be 1,200. I knew the maximum couldn't be negative 70. That would make absolutely no sense. So, I mean, profit can be negative, and your total profit function can be in the red. I mean, that happens to people. However, in this context of this problem, I didn't think it was. And so I just want to see what makes sense, and I always want to double check. And that made me actually rewrite the function into my calculator, and then everything was correct. So something to really watch out for, and something that I've always said is, always try to make sure that your answer makes sense in the problem. So let's combine these. And one of the really nice things that your calculator can do is make factoring about 10 times easier. So let's say I have something annoying like this one. 0 equals 5x squared plus 13x minus 6. Well, I want to find the two intercepts, so I would want to factor this. So 5x and x, I know, and one's positive, one's negative, and I know all of this stuff. But instead of sitting here trying to figure it out, what I could also do is I could graphically find one of the x-intercepts of the function. So I'm going to make my y1 equal to this. So now I'm going to go back to y1. Let me clear the 1200 that we did on the last example. And we have 5x squared plus 13x minus 6. Let me delete the rest of this so that it's, whoops, it's deleting the wrong way. Go up here, delete everything. Now it's deleting the right way. All right, machine. Okay. Delete, and there we go. Does that look right now? All right, we got half of it. 13x minus 6. Okay, so we put that in there. I'm just going to zoom this to standard now. Zoom 6. See what it looks like. We don't get a complete graph, but in this case, we don't necessarily need one. What we just needed was the intercepts here and here. Now, this intercept to me goes through what looks like a whole number. So I'm going to find out what that one is. Because as soon as I find out one of them, I can easily find out what the other one is, right? So if I go to calc, I want to find a 0. So I need a left bound. I actually want to go the other side. Oops, went too far. Oh no, I didn't. The left bound, my right bound, that's good enough. And my guess is going to be the same as my right bound. And I get a 0 at x equals 3, y equals 0. So I know, or negative 3 rather. So I know that x equals negative 3 is a 0 of this function. So now I know that x minus negative 3 or x plus 3 is a factor. So what I can do, so algebraically verify is an exact solution to the function. All right, fine. That just means plug this in. 5 times negative 3 squared, and notice I put negative 3 in parentheses, plus 13 times negative 3 minus 6. Let's see what that equals. 5 times negative 3 squared is positive 9, so that's 45. 13 times negative 3 is, oops, I was already in the next one. Brain gets ahead of me. Minus 39 minus 6. 45 minus 39 is 6, minus 6 is 0. So it is an exact. So now we know that x plus 3 is one of the factors of this. So now we know what the other one is. So we know it has to be the other factor of 6 is 2. And we know that it has to be a negative 2 times a positive 3. So we know this is negative 2. So we know it's negative 2 plus 15 makes positive 13. So we know the other solution has to be 5x minus 2 equals 0. So 5x equals 2. So x equals 2/5. So now we have both solutions. x equals -3 and x equals 2/5.